So today we start solving multi-step equations, basically more than one. Could be 2, 3, possibly 4. Most of today's will be under 3 steps. So we're going to solve the following equation for the missing variable. So in this case our missing variable is n. And what I'd like you to try to do when you solve any kind of multi-step equation is, when there's no fractions, I'd like you to try to do all the addition and subtractions. Deal with those first, so get rid of those, and then follow those up by the multiplications and divisions. So in this problem, we need to isolate the n, get this by itself, but in order to do that, we have to undo this subtraction of 5 and undo this multiplication of 3. I'll undo the subtraction first by adding 5 to both sides. We know that 5 minus 5 is 0, leaving us with 3n. And 7 plus 5 is 12. Now I have to undo a multiplication of 3, so I'll multiply both sides by 1/3. In theory, I could divide by 3 to both sides, but I'm just going to use the 1/3 multiplication because it'll come in handy when we get to fractions. Next, 3 times 1/3 is 1, so I have 1n is equal to 12 times 1/3 is 4. So n's equal to 4. We're just going to go ahead and check this real quick to make sure we did it right. So if I have 3 times the quantity of n, and n is equal to 4, subtract that by 5, that should equal 7. I have 12 minus 5, which is 7, and 7 equals 7, so this problem checks out. And we'll do this from time to time, not every time, but time to time. You should be able to check all your answers and get them correct. So here we go again. We have a couple equations. I'm going to undo the additions and subtractions first. This is written backwards, but in theory, here's our multiplication of 6 times n, and here's an addition or subtraction. The key is it addition or is it a subtraction? This is 8 minus 6n. So in theory, this is 8 plus a negative 6n. So this is an addition. If I want to undo an 8, a positive 8, I have to add a negative 8 to it. So I will add a negative 8 to this side. 8 plus negative 8 goes to 0. I'm left with a negative 6n is equal to negative 3 plus negative 8, same sign. So I keep the negative, add the two numbers, and I get 11. Now what I'm going to do is undo this multiplication of a negative 6. If I want a positive 1 here, I have to multiply by negative 1/6 to both sides. We multiply two negatives together, we get a positive, and 11 times 1/6 is positive 11 over 6 is equal to 1n. Moving to the next problem. This is our multiplication with the 4 times the x. So therefore this must be our addition. I want to undo an addition of positive or of negative 5. So I'm going to add a positive 5 to both sides. Negative 5 and positive 5 go to 0, leaving me with 4x. This is a negative 12 plus a positive 5. Going to keep the sign of the bigger number, which is the negative. Subtract the two, get 7. So negative 12 plus positive 5 is negative 7. Now I have a multiplication of 4 to the x is equal to negative 7. I can multiply by 1/4 to both sides. Or if you feel like it, divide by 4 to both sides. That works as well. Negative times a positive is a negative. 7 over 4 is equal to positive 1x. Now, When we deal with fractions, what I like to do is actually get rid of the fractions because most people aren't comfortable in using those. So I use a process called clearing the fractions. And clearing the fractions involves the following. When there's a fraction, what you want to try to do is find the lowest common denominator of all the fractions in the problem. And then multiply each term on both sides of the equation by that LCD. So I take a look, and in this side of the problem, I have a denominator of 10. In this side of the problem, there is no denominator, so it would have to be 1. The LCD, in this case, is 10. So what I'm going to do is I'm going to multiply each term by 10. Now, in theory, this is only one term. So if I multiply the entire equation by 10, it's like a large distribution, if you will. So I multiply this by 10, and I get 120 times 10, or 12 times 10 is 120. If I multiply this entire term by 10, notice 10 over 1 and this 10 reduce. So I'm just left with 4 plus x equaling 120. Now I have to isolate the x, so I have an addition of 4. I'm going to subtract 4, or I can add a negative 4. Doesn't really matter. And in this case, I have 116 is equaling x. If you wanted to check that, once again, we'll go back and do that. I have 4 plus this unknown value of x, which is 116, over 10. That's 120 over 10, which equals 12. And that's what my equation equals, so that checks out. Here's a very similar problem. Let's just do it again. In this case, I have a division of 2, which is really like the denominator in this case. Over on here, I have a denominator of 1. If I multiply both parts of the equation, or all terms in the equation, by 2, because that's my LCD, then notice on the right side, I get negative 16. These 2's are going to reduce, leaving me with 5 minus 3x. I need to take, in this case, I have a subtraction of 3x here, so this is a multiplication. And then this is a positive 5. So if I want to undo that, I'll add a negative 5 to both sides. Positive 5 and negative 5 go to 0, leaving me with negative 3x. Negative 16 plus negative 5, same sign, so keep the negative and add the two numbers. That's 21. I'm going to multiply each side by negative 1/3 to undo my multiplication of negative 3. Negative times a negative is a positive 1x. And 21 over 1 times 1 over 3 gives me a positive 7. So x equals 7 in this case. In our next problem, we see we have denominators of 1 on the right, and I have two terms on the left. This has a denominator of 3, this has a denominator of 1. So the LCD for all terms is equal to 3. I'm going to multiply each term in the equation by 3. So I'll multiply this by 3, this by 3, and this by 3, and clear all the fractions out. 3 times 6 is 18. Notice the 3 and the 2/3. Well, I'll just show you the multiplication, then I'll reduce later. I have 3 times 2 over 3a minus 3 times negative 3 is negative 9. Now in this case, these 3's, 3 over 1 and 3, will reduce out. So I'm left with 18 plus 2a is equal to negative 9. I need to get rid of this 18 before I deal with the multiplication. So in this case, I'm going to add negative 18 to undo that, or I could subtract 18, it doesn't matter. So in this case, I have 0 plus 2a is equal to, both these terms are negative, so I keep that sign, add up, I get 27. And then I'm going to multiply by a half, or I could divide by a 2. So in this case, I get negative 27 over 2 is equivalent to 1a. Let's do another example. This is more complicated. I have 3 terms. 5 is one denominator, 2 is another denominator, and 4. So I need to find the lowest common denominator such that all of these go into it. And the way I do this is I usually start with my biggest number and I say, okay, if I use 5, will 2 and 4 go into it? No. So now I double 5, make it 10. 2 goes into 10, but 4 doesn't go into 10, so that's not going to work. Then I try again, and I say, well, how about 15? 2 doesn't go into 15, that's not going to work. I go to 20, 5 goes into 20, 2 goes into 20, 4 goes into 20, so that's my LCD. And I'm going to take and multiply each term by 20. I'm going to write it in this way. 20 here, 20 here, 20 here. So notice what happens. These reduce to a 4. And what's left is 4 times 2. These two reduce to a 10. So what's left is a 10 and an x. These two reduce to a 5. So I have equaling negative 5 times 3. Combining those, I get 8 plus 10x equals negative 15. I need to undo this 8 because this is a multiplication. So I'm going to add a negative 8 to both sides. Giving me a negative 23 is equal to 10x. Undo that multiplication of 10 by multiplying by 1/10 to both sides. Or again, you could say divide by 10 to both sides. 10 times 1/10 gives me 1x. And I have negative 23 over 10 is what my x value is equivalent to. In this case, I've got 2 fractions because my third has a common denominator of 1. Start at 6, and we know 5 doesn't go into that, so double it, 12. 5 doesn't go into that. Triple it, 18. 5 doesn't go into that. Times 4 is 24. 5 doesn't go into that. Times 5 is 30. And 5 and 6 go into 30, so that's my LCD. I'll multiply each term by that LCD. So once again, I'll show it a little bit different way this time. I'll take and multiply everything by 30. So what I have 30 times 3 minus 30 times 4x over 5 equals 5 over 6 times 30. So notice in this case I have 90 here, doing my order of operations. The 30 and the 5 reduce to a 6. So I have a total of 6 times 4x, or 24x. And in this case, my 30 and my 6 reduce to a 5. So I really have 5 times 5, which in this case is 25. And now I have to solve this multi-step equation. Since the 24x is the multiplication, I'm going to deal with the 90 first, so I'm going to add a negative 90 to both sides. This goes to 0. I have negative 24x. Now the 90 and the 25 have opposite signs, so I'm going to keep the sign of the bigger number, which is the 90, and then I'm going to take 90 and subtract 25 from it and end up with 65. So now I have to undo the multiplication of negative 24. I'll choose to multiply by negative 1/24 to both sides. And you'll notice this multiplies to a positive 1x. This multiplies to 65 over 24. And that's my solution. I'm going to jump in to a similar problem, but there's a little twist to it. It says, if 2x minus 5 is equal to 35, what is the value of 4x minus 10? Well, I'm not going to know this value until I find out the value of x. So I'm going to solve for x in this problem first. So in order to undo this subtraction of 5, I have to add 5 to both sides. I have 5 plus negative 5, or 5 minus 5 is 0. So I have 2x is equal to 40. I can divide by 2 to both sides, or I can multiply by a half. I'll divide by 2 this time. So divide by 2, and x equals 20. Well, if I know x equals 20, and I want to find the value of 4x minus 10, I go to this right side and I say, well, 4, if x is 20, I make a substitution. And then subtract 10. Order of operations says I multiply 4 times 20 and get 80. Minus 10 is 70. And that's my solution. Next, little more word problems. This time we're introducing the concept of consecutive integers. Well, a consecutive integer is an integer that follows directly after another integer. And we remember integers are both positive and negative counting numbers. The problem is I don't know where to start. So if I don't know where to start, I have to have a first, a second, and a third consecutive integer. The first one I don't know, so I'm going to call that my unknown x. Now the next one is immediately following that, so it's one more than that, or x plus 1. The third one is one more than the previous, so instead of x plus 1, I add 1 to that and get x plus 2 for my third integer. Now I'm going to add all three up because this says the sum of 3 consecutive integers. So I'm going to take x plus 1. This is the first, the second, and then x plus 2 is the third, and they're supposed to all add up to negative 21. So now I'll add like terms. I have x plus x plus x, which is 3x. 1 plus 2 is 3, and that equals negative 21. I'm going to solve this by undoing the addition of 3, so I'm going to add a negative 3 to both sides. This gives me negative 24 is equal to 3x. Since 3 goes into 24 evenly, I'll just take and divide by 3 to both sides. 24 divided by 3 is 8, but I have a negative and a positive, so this is going to be a negative 8 is equal to x. Now the problem asks me to find 3 consecutive integers. So my x is my first, and that's going to be 8. My second is equal to x plus 1. So what I have is negative 8 plus 1, which is negative 7. And my third is x plus 2. And I know x is negative 8, so negative 8 plus 2 is negative 6. And if I take and add negative 8 plus negative 7 plus negative 6, I end up with negative 21. So this problem checks out. So now we're going to talk about the sum of two consecutive odd integers. Well, think about what an odd integer is. If I take any integer like 25, that's an odd integer. The next odd integer wouldn't be 26 because that's even, it would be 27. Then the next is 29, etc., etc. And you'll notice the difference between all these is 2. So my first, I always use as x. My second is going to be, instead of 1 away, it's going to be 2 away. So it's x plus 2 away. And it says the sum of two consecutive odds. So I add the first to the second and get 88. In this case, I have 2x plus 2 equals 88. I'll add a negative 2 to both sides to undo. Get an 86 is equal to 2x. Since 2 goes into 86 evenly, I will just take and divide both sides by 2, giving me x equals 43. And I'm looking for two consecutive odds. So my first is 43. My second is equal to x plus 2, we said, which is 43 plus 2, or 45. So do 43 and 45 add to 88? Sure do. So it checks out. Next, it says 16 is 7 plus 3 times a number. And I want to find the number. Key word in this case is, and that's our equal sign. So it says 16 is 7 plus 3 times the number. I'll use n for the number. So here's our equation. I have to undo the constant term first because I have my multiplication here. I'll add a negative 7 to both sides. 16 plus negative 7 is a positive 9. That gives me 3n. Since 3 goes into 9 evenly, I'll just divide both sides by 3. I could multiply by a third. So, well, I get n is equal to 3. And then I can check this to make sure. I have 7 plus 3 times some number. Our number is 3. That better be 16. I have 9 plus 7 is 16. So it checks. Next problem. We have Ty has a total of 92 coins. And that 92 coins represents 8 more than 3 times the number of quarters he has. So that 92 is 8 more, so 8 plus, 3 times his quarters. And we want to know how many quarters he has. So again, this is similar to solving the last problem. Add negative 8 to both sides. We get 3q on the right. 92 minus 8 is 84, I believe. So then if we take and divide 3 to both sides or multiply by a third, doesn't matter in this case. I get Q equaling 84 divided by 3 is 28. So I have 28 quarters